Let's say you have a small inverter, possibly a small power station or a small standalone inverter. And you see on the internet that this should maybe be bonded or grounded or something, and you go, well, can I hook this up and bond it and ground it? Maybe through a breaker panel. In some cases, you may be able to do this, but in many cases, it's very dangerous to do it. Let's take a look in this video. There are many small inverters available online, and many of them are relatively inexpensive. Most of these have 120 volt AC outlets built in, so you can plug in a computer, lights, small appliances directly into the outlets. Power stations have their own built-in batteries, but similar to the small inverters we're looking at, they will also have AC outlets directly on them. Back to these standalone units, they're not made to be mobile. They're made to be attached to the wall and used in your house or in one place. Many of them have these outlets right on the front that you can plug your lights, circuits, appliances into, or you could use extension cords to run through your house. If you would like to be able to use these as backup power for your house and tie into your existing breaker panels, then there are some very important considerations. First, these need to create true 120 volt output. Okay, so on these cheap inverters, especially the ones that have the AC sockets on the front, a lot of them are wired this way. And it's kind of odd. You're going to have not 120 volts coming out of the line, you have 60 volts coming out of the line. The neutral is not the return for the line, it's another 60 volt line. You can actually think of it as a line 2. And if this was line 1, line 2 would be 180 degrees out of phase with that. It's kind of strange. If you measure across line and neutral, it's 120 volts. It will run your circuits. You plug things in and you won't realize anything is different about this. If you measure from line to ground, it's 60 volts. And this is not a ghost voltage. And here is across neutral and ground, you're also going to measure 60 volts. So if you were to bond this neutral and ground, you are constantly putting 60 volts of real voltage on your ground cable. So a very dangerous situation. Also, these inverters have a tendency to burn up when you bond the neutral and the ground. To make things even more confusing, there is something called ghost voltages, which can appear across an unbonded inverter, which is very different than these real voltages, which are dangerous. I go into all the details of that in this video, bonded or unbonded. You can check that out when you get a chance. So the first consideration was that we have true 120 volt output. The next thing is we want to look for terminal block wiring. So whether or not you have AC outlets, you are looking for a terminal block that you can wire your neutral, hot, and ground directly to. Someone mentioned this G&L in the comments and said it worked really well for them. So let's take a quick look at it. And you can see that there is a terminal block with a hot, neutral, and a ground, and it puts out 3,000 watts. Now, this unit was an inverter from CNBOU that I had several years ago. It does have a terminal block. However, you could not tie it into your existing house circuits because the inverter was bonded. And we'll come back to that in just a second. Our next consideration is, can we find some documentation? And this can be a hard one, but there are companies that put out great documentation so that you know you are safe to hook this up to your AC wiring. Okay, so this is a Sigeneer 6,000 watts low frequency inverter. Comes with really excellent documentation. And here they clearly show you how to wire the AC input and the AC output. And this is for the 120 volt version. And this is for wiring up the split phase, which is 120 volts and 240 volts on it. And next we need to talk about bonding of the inverter. Is my inverter bonded or floating? If it is bonded, that means the neutral and the ground are electrically connected together. If it is not bonded, sometimes known as a floating neutral, the neutral is not connected to the ground. Rule number 1, there can only be one neutral ground bond in your entire electrical system. In North America, your main panel is where you're going to have your neutral ground bond. So you cannot have that bond in your inverter. The big takeaways from this video: you don't want to use cheap inverters that only give you 2 legs of 60 volts. You cannot tie that into your house wiring. If you try to bond that, it will burn up the inverter. You're also looking for terminal block wiring. You're looking for good documentation, and most of the time you want to use an unbonded inverter. The exception to that might be a dynamically bonded inverter, which we talk about in Grounding and Bonding Part 3, if you want to know more about that. So let's quickly talk about power stations. On most portable power stations, they are not bonded. In fact, there's no connection at all to the ground. And if you look on this one, you can see there's not even a ground socket. It's just a hole where the ground pin goes in. Here's an old power station that I bought years ago. I don't even think they make these anymore. But it's on and running. Not sure how the battery is going to hold up on this, but okay, we're going to test it. And we have the one red light on. It's showing a bad ground. Actually, there's no ground. Okay, between hot and neutral, it's showing 114 volts. Like I said, the battery's about shot. But between neutral and ground, there's no voltage. And hot and ground, it's also showing no voltage. Most of the smaller power stations are not bonded and may not even have a chassis ground. I suppose they don't have a return path for a ground fault unless you were touching maybe both the hot and the neutral wires at the same time. They seem to work fine to run circuits while camping, boating, etc. Now, some of the larger units, such as the Anchor Solix and the EcoFlow Delta, do allow you to use them to connect to your breaker panel for backup power. The Solix not only has 120 volt outlets, but it has some 240 volt outlets on it as well. And from what I can tell, this is unbonded and gets its bond from the house when you plug in the charging cable. And they sell it as a kit along with a Reliant transfer switch. EcoFlow sells a number of models like the Delta Pro, which comes with expandable batteries, and they also sell a kit that you can use with a Reliant transfer switch. To get 240 volts, you have to hook 2 units together through this, which is called a double voltage hub. These also seem to get their bond from plugging in the charging cable to your AC circuits. Personally, I think you get more bang for your buck out of all-in-one units like these, but of course everyone's needs are different. Grounding and bonding is a really confusing subject. If you're new to this or you're confused, go check out my whole series on grounding and bonding for solar inverters, part 1, 2, and 3. I'll put a link below and up here on the screen. That wraps it up for this video. See you in the next one.